We've been using Hitec products here at Two Brothers Hobby for a number of years, and everything's performed flawlessly. With their expanding product lineup, Hitec not only dominates the worldwide servo market, but has made an impressive showing with their comprehensive charging products as well as their weekender line of aircraft. Last fall, they released the Aurora 9X radio system, setting a new precedent with having the highest resolution and the lowest latency in the industry. Their latest offering, the Flash 7 radio, sets a new precedent as well by bringing that 4096 resolution and the 7 millisecond latency to the $175 radio market. Now, the functions and features of the Flash 7 are far too comprehensive to cover in a brief overview, so we put together this overview and programming clinic. Now, throughout this video, you'll see a menu in your bottom right corner of your screen. You can click on this at any time, and it'll return you to the scene index so you can navigate your way through the lessons. As we look at the current product lineup, the Flash 7 falls just below the flagship Aurora 9X. Due to the fact that its built-in AFHSS module supports both Gen 1 and Gen 2 protocols, as well as SLT protocol for the popular TXR or transmitter-ready aircraft. The majority of the aircraft on the market only require 6 channels or less for operation, so the Flash 7 is viable even for hardcore pilots flying like giant-scale aircraft. The Flash 7 can operate all the Gen 1 and Gen 2 Hitec receivers currently available, including the new Maxima SL S-Bus receiver, and that opens up a whole new set of options for flybarless heli pilots. Tie a Maxima receiver to Hitec's ultra-high-res digital 7000, 8000, or 9000 series servos, and you have the industry's only 4096 resolution control for unprecedented precision and performance. To add icing to the cake, the Flash 7 is compatible with Hitec's line of telemetry components, with full support of their advanced sensor station and compatible sensors when used with an Optima 7 or Optima 9 receiver. As you pull the Flash 7 out of the box, let's get familiar with all of its basic attributes. A power switch located in the center, radio strap right below that, trim tabs or digital trims for the 4 primary channels, both located on 2 gimbals. These are ball bearing gimbals, and they are height adjustable as well on the sticks. We have 6 assignable switches on the top. It's actually one's a button, 5 are switches. 3 position, 2 position A and B. C is military push button. D is 2 position, as well as F, which is typically used for a trainer function. The 3 position switch, of course, being on E, is fully assignable. Common use, normal, stunt 1, stunt 2 for helicopter mode, but it can be assigned to any function. We also have a status indicator up above, which we'll show you in a little bit. Then, of course, our main display, our LCD backlit LCD display. Our navigation buttons are located here. A turn, our rotary dial, push button for execute, and a back button. Very simple to navigate the menus. Continuing to the sides, we do have 2 assignable sliders on both right and left-hand side. On the back, we have the data port, we have the trainer port, and we have the DCS port. Now, the data port is where we would use an HPP22 or one of the other PC programmers to either update firmware on the radio system, pull model profiles down, upload profiles to the memory or to the model for saving. So that's how we get our model profiles inbound, outbound, is through this PC programmer as well. Below that, the trainer port. This, of course, used for trainer function on a slave radio. It can also be used for head tracking. The DCS port can provide power for a head tracking unit. Other than that, at this time, it doesn't have any other functions. But you can use that for power for your head tracking interface. Battery cover. Right now, it comes by default with a 4-cell tray that is removable. And as you can see, that uses a standard radio connection, so you can use a rechargeable battery. This does support multiple chemistries, which we'll show you once we get into the menu features, but we just use a standard right now, 4 alkaline batteries in the battery tray. On the side of the radio system, there is a charging port, so if you want to use a rechargeable battery chemistry, you can charge it through the charging port. And that pretty much wraps up the physical layout of the Flash 7. When we power on the Flash 7, now keep in mind we're on camera, so we need to watch our contrast. This is a very bright backlit display, so I've actually disabled the backlighting on it. When we first turn it on, it will flash the logo, and it'll also kick the status indicator on. Now I've chosen again to turn the backlight out. I'm going to tell it not to transmit. When you first pop it on, one of the menu options is to verify whether or not you want to transmit anything or just work through the radio system. You can turn the antenna off, which of course is going to save battery. but it allows you to do changes and make modifications to a model profile without actually triggering anything on the model if the model happens to be on. Of course, it shouldn't be if you're just powering on your transmitter. It should be in the opposite direction, but regardless, we do have the option of, do we want to transmit or no? If we're making system changes, I'm going to choose no. So using our navigation button, all we do is press down, and it'll choose the highlighted option. Now when we sit on the main screen, you can see since I chose no, it turned our status indicator green. If I chose to transmit, we'll go ahead and cycle that again. If I choose to transmit, yes, and I hit enter, the status light will flash green quickly but then stay blue. This blue color is what you want when you're actually active transmitting. So keep that in mind. That's already our first level of status indication. We'll go ahead and cycle it again and tell it not to transmit. And now when we look at our main screen, we have our model name indicated here. It shows what type of aircraft that is. If it's set up to, glider, acro, or heli. This is our flight mode indicator. So right now it's on normal. Prior to this clinic, I went ahead and set up just another flight mode when I assigned it to switch B. So when I throw that, it'll show the condition and whatever flight mode you're in. And there's multiple flight modes that are supported by the Flash 7, which is another advanced feature you typically don't see in this class of radio. This indicates our onboard battery. So our current 4 cells are at 5.7 volts. This is total radio timer. You can reset this, but it shows total radio active time. This is timer 1. There are 2 timers that you can adjust within the Flash 7, so we'll show you that as well. And then at this point, it's kind of cool to notice at the very bottom you see it says OPT-MIN. That's Optima Minima Receiver is what it's indicating. And if you scroll through just from your main screen, back is not going to do anything typically. All you're going to do is use your scroll wheel, and it gives you 4 different options. One is where, again, showing the model, you can hit enter. You can choose additional models right from that main screen. It'll stop the radio and restart the radio. Normal, of course, we can hit enter and choose one of those conditions. And again, the conditions will look differently on sailplane as well and other types of aircraft that you choose. Hit your back button to go back. And then if we go down to Optima Minima, we hit enter on that. It gives us our spectrum module control, which is kind of cool. That's actually in the system management level of the menu navigation. But right from the main screen, it gives you the option to do your binding. So you can do your range check, your binding, or switch over to scan mode, which we'll explain later. Go back, and then we have our timer. We can choose which timer we want, and we can also choose those settings. Is it an up timer? Is it a down timer? Is it a switch? Is it assigned to a gimbal? Is it assigned to a switch? How do you want it to function? So we have all those basic and typical or common functions right there from the main screen. As we go down through the menu, we have 2 additional layers of menuing then, of course. If we push and hold down the main navigation button, it'll go into the main menu. And then we have another layer too, which is a system menu. If we scroll down through our main menus, so you have two pages of that. So make sure you don't forget options or settings on that second page. And then if we go back to our main screen, if we hold down both buttons, both the back button and the execute button, that'll take us to our system menu. And this goes to that deeper layer in the radio because we do have our basic model select functions, model types, and when we start getting into our channel monitors and all those cool functions as well, including management and then of course info if we want to take a look at what version of firmware we're running and what language. Again, back to back up one level. Management will give us some of those advanced features as well. Backlighting, that's where I turned it off. Contrast, what type of battery, user interface feedback, and then of course warning setup, which all again we're going to cover in detail in a little bit. So let's go back out to the main. That's our main menu navigation. So as you use the Flash 7, you're going to be using those layers, those 3 layers essentially. Your main screen shortcuts, hold once, your main menu, hold both buttons, and we're in the system menu. Let's go ahead and set up a test model. Right now it's sitting on no name 1, which is a standard one that's in the radio system. We'll go ahead and there's 2 ways to get into new model setup. It's the same way you select the model. So if we're on this main screen, we can scroll to the model name, no name 1, hit the enter, and it'll take us to our select screen. We've got a test acro I just put in there. So we can play around and see more than one on the screen. If we want to create a new one, just choose any one of them and hit your enter button, and you're going to see new, copy, reset, and rename. So this is where we can rename that no name 1 if we want to. can go ahead and choose New, hit Enter. Create to new model, yes. It's going to go ahead and give us the option then. While that's happening, we have two different ways, they said, to get in. We can go through our main menu, which is both buttons depressed, and then we can choose models there, or from our main screen, we can simply scroll over. That's by far the easiest way. So now it's going to ask us what kind of model type we want to set up, Acro, Glider, or Heli. Let's go ahead and just do a simple Acro setup. We'll enter on that, and now it's going to give us the option to scroll through from the model type, the wing, and the tail type. Or wing type, hit enter on that, and we've got one aileron, one flap servo, one aileron, two flap servos, and down through the list. What you will notice as we continue to scroll is normal is going to change to, there we go, delta elevon setup, which is two ailerons, but the type of wing is a delta or elevon, meaning that the elevators and the ailerons are functioning on those same two servos, so it'll do the mixing inside the radio as necessary. So we can go ahead and, again, add flaps to that. There's a few options within our delta elevon. Let's stick with one aileron as a normal setup, so a single aileron servo. So say we're doing it as a regular 4-channel setup with one aileron servo, or well, most commonly, let's see, we'll take it to 2 ailerons. That makes the most sense. So that's a basic setup on a 4-channel. The tail type, we can choose our tail type. So we have the option of normal, V-tail, or elevator. So again, all going back to the type of configuration that you're flying. And then back to normal. So let's do it as a normal setup right now. So now we have, it's an Acro with 2 ailerons and a normal tail. We're going to go ahead and hit back here, and then it's going to take us right, the automated process takes us right to the Spectra module. So this is where ID linking and binding come into play. We're going to go ahead and skip this right now. I'm going to take you back into it because I want to finish up this model setup. So I'm going to go ahead and hit back here. And then there we are. We're on our Acro 3 no name. This is the one we just created. So let's go ahead and rename that real quick. And we hit enter, go in here. You can rename it at any time too. Just go into the model select screen and choose rename. This first function is it's going to scroll between the characters that are in the current name. And then once you depress the enter on that, then you can change through the full list of characters here. So let's go ahead and get rid of that 3 on the end, hit enter, back up to this blank space. And then after this tutorial, before we move to the next, I'm going to turn that button beep off. There we go. And then we can scroll back to the hyphen, enter on that. Actually, I'll go to the right, that's a little shorter. There we go. No name on that. Scroll back to the E. Now I can start renaming it. So we'll go ahead and call this test. Acro. There we go. Okay, so now we got name test Acro. Once I exit out of the character selection for any of the particular characters, then I can just hit back, and it renamed it to test Acro. I can copy the model from here. I can reset all the parameters on the model from here. If you kind of get lost in the woods of settings and things are going crazy, you can always kind of back up to 0 and say, all right, I'm going to reset all my dual rates and all my trims and all that stuff from here. Or, of course, I can rename it. We'll back out again, and now we're back at the main menu. Easiest way is right there. It says Maxima. It's the last model that was bound, had a Maxima receiver. Of course, our kit came with, we had a heavy-duty power switch that came with ours, because we didn't get the base radio. We got the radio with the Optima 7 receiver. And here's the Optima 7 receiver. It also included then a pigtail for our SPC port, which is supplemental power connection, a pretty cool feature that you're going to want to look into as well, and we actually do separate clinics on that, and those clinics are the same regardless of the transmitter. The SPC function is the same on the receivers. And then it also included a small Boda antenna holder for the Optima 7, so you can mount your antenna inside your model and have a little bit of vibration protection on it. And then we needed a power supply of some sort to plug into our receiver, so we went and grabbed the 2700 milliamp receiver pack. And this is 7.4 volt. The Optima series will handle 4.8, 6.0, and 7.4, 7 volt high voltage. Of course, always made up your servos that you're going to choose for your model with the incoming power supply. If we've got 7.4 going to our receiver, we better have high voltage servos, which we have a couple here to test with some horns stuck on them. So let's go ahead and do the ID linking and binding. All we do is scroll down the easiest way, again, Maxima right there, or we can go into our system menu, hold down both, and then we can go into our Spectra module right there, choose Spectra, and have the options that we're going to see back out, Same options if we just scroll down on the main screen and chose what it was currently set on, which is maximum. We're going to go ahead and enter into that, and we have our options. So let's go ahead and scroll over to, there it is, to maxima, hit enter, and we're going to switch that over to what came with our Flash 7, which is an Optima 7. So we want the Optima or Minima options. If you can't find it in one direction, just scroll back, you'll find it. There's Optima and Minima. Now we'll go ahead and hit enter on that, and it's going to give us two choices. Do you want a radio stop? Yes, it's going to stop our radio. Right now it's blue, showing that we're transmitting. It's going to put us in green mode. Check your situation, ready to transmit. All right, we're going to continue transmitting now. Optima and Minima, we're going to go ahead and move down to binding, and it's going to give us the option Optima or Minima. We have an Optima 7, we choose that. Do you want to bind radio stop? Yes. Press and hold the link button on the receiver and turn on the power. So we're going to go ahead and connect our power supply battery to our receiver. It can go in any one of the channels, and the fact is these are all shared buses between them, with the exception of the SPC port and the data port. All of these are a shared bus, so I can plug into any one of these. I'll go ahead and plug into the battery just for the demonstration. It was already powered on. Let's go ahead and turn that off. And then we'll hook up a servo to channel 1 just so we can see our status, make sure things are working. So we've got our servo plugged into channel 1, our battery into the battery port. Now it's telling us to go ahead and press and hold the link button, which is right here on the front of the radio, or on the front of the receiver is the link button. Always just leave that in its mode, push down link, hold it, and turn the power on. And right there you saw the screen change in the transmitter. You can release as soon as it comes up. And it says it's binding to an Optima. Reboot receiver and check all functions if correct. Leave the transmitter on, turn the receiver off. You won't have control right now. Turn the receiver off, turn it back on, and we should have, there we go, servo control on channel 1. Alternatively, we can choose to bind to a different radio system, and we can also go into, I'll choose finish here, we can go into scanning mode. So there's a few different ways we can actually communicate with our receiver. One way is through standard normal mode, where it just breaks up across 2.4 gig, grabs a few channels and says, all right, we're fine. You know, I've put data here, you know, across the 2.4 gig range. So with that diversity, we should be fine. If there's a little bit of interruption in between, we still have good signal strength, good communication. The other way to go, if you're in a heavily congested environment, you know, 20, 30, 40 pilots powering on at any given time at a huge flying event or something, and you really want to make sure, or you have, you know, potential 2.4 gig RF interference, not too severe. You want to make sure you aren't flying in heavily congested areas, but if you need to work around some 2.4 gig traffic, you can move into scanning mode, and we'll show you how to do that. If we go down to our Optima Minima, our receiver, you know, our bound receiver type, hit enter, and then we go ahead and go scanning. All this stuff will be correct. We're just telling it to go from standard binding, which says, all right, I'm going to bind to these, and when I power on, I'm going to pick some channels, and I'm set. And whatever I've got is what I've got. If something interrupts it, I'll do my best to continue communicating. We're going to scanning mode, so we hit enter and scanning. And so you're sure you want to scan frequency table, radio stop. Let's go do a radio stop, yes. And it flashed very quick green back to blue. It's scanning the frequencies now. It's looking at all the interference out there within 2.4 gig. Now it's found acceptable channels or a clear frequency area. So what we're going to do is we're going to hold our link button down again. Kick it on, see if you can see that. We're going to let go of the link button, and it just bound itself to the Optima 7 in scanning mode. So what we're going to do is reboot it then again, turn it off, turn it back on, make sure we've got functionality, and now we're in scan mode. There are some limitations that kick in within scan mode in terms of reconnecting in the case of signal loss and stuff. So you're going to want to better understand scanning mode versus normal mode. In most cases, normal mode's just fine, just bind it as is, and we've never had an issue. We've never run across any problems with any of our high-tech systems having loss of communication, even at fun flies and stuff. We just use it in normal mode. We have in some cases in a very congested area, and when we did have signal interference at a particular show we went to, we switched over to scanning mode, and we were the few people who were able to get communication to our models and fly them safely, while some of the other radio manufacturers' equipment was grounded because they just couldn't get enough clearance within the 2.4 gig band. So very interesting feature, something to keep in mind. We'll go ahead and choose finish. We're going to move that back into standard bind mode, so let's go ahead and turn our Optima off, and we'll go into our settings here, and we're going to go back into binding, which is normal mode. And we got an Optima, so we're going to choose that. Yes, we want a radio stop. We'll quickly flash green back to blue. Press and hold the link button on the Optima. So we'll do that. We'll turn it on. And there it is. It found it. It's saying to go ahead and turn off the receiver. Turn it back on. Verify functionality. And we're finished. And that's receiver, binding, and linking. Same process. You'll see some different flash indicators going on depending on the type of receiver you're using. There's a Maxima 9, which is the digital-only receiver. It's also going to give you your 4096 resolution and your crazy low 7 milliseconds latency. This is the type of receiver you're going to want to use for if you really want to take advantage of those features. It binds the same way. Turn it off, press the link, turn it on. It does, it flashes its lights and it finds it. You just follow the prompts on the Flash 7. Extremely easy ID linking and binding on this series of radio. Okay, Acro Features. As we choose different model types, be it Acro, which is your airplane, fixed wing airplane, or glider or heli, we're going to get some different menu options when we go into our first layer of menuing. And again, a lot of the choices you make can affect your options as well, so you're going to want to go through and explore the manual in depth. But this will just be a highlight skim through what functions you'll see on Acro. We'll go ahead and hold down our menu button. We've got servo reversing, common, sub-trim, dual rates and Expos, EPA, servo speed, all common to all types of models. You get into throttle cut. So we do have a throttle cut option. We can go ahead and activate that, assign it to a switch, and make adjustments as to how much further it throws that, that throttle channel when your throttle cut kicks in. Normally you would assign it to a switch. In the up position, say for example, you've got your bottom point moves up slightly in the servo travel, and then you have your full throttle range. When you zero the throttle then and throw your throttle cut in, it'll drop it down a little bit further to bring it down to a very slow idle in some cases, even just kill the engine altogether. There's of course some other options as well, from optical throttle cuts circuits and some other BEC based circuits as well. But your throttle cut is going to be an easy way to affect that throttle channel and do your engine cutting, your idle cut. Program mix, so you have programmable mixes available on all model types. Aileron rudder, so we can go aileron rudder mixes that are built into this particular layout. We can go ahead and activate that. And if you want to smooth out some of your aileron rolls, things like that, you can adjust your aileron to rudder mix and flatten out those turns a little bit on your rudder turns. A lot of different options there as well. Again, going back to more advanced programming capabilities. Throttle curve, we do have a throttle curve with an Acro setup. We can put that in. Let's go ahead and take a quick look at that. Standard is 0, 25, 50, 75, and 100 is a 5-point curve. So say for example you're running a fuel engine and you notice that even with your mix, your low and high speed mixes properly set on the engine, you're getting good RPMs, you're getting nice temperatures and good performance, but you notice that your throttle just isn't quite as linear as you'd like it. Now that all comes down to the carburetor design, the manufacturer setup. It may not be a terribly linear throttle. You may have a lot of, what I've noticed mostly is a lot of response to the lower end, and it kind of just gets a little muddy at the top. From 75 to 100 doesn't make a big difference. Well, I want it to make that difference. I want to achieve my maximum RPM, 50% of my RPM, and then my lowest idle in a linear fashion across my stick. This is where I can apply a curve. Dial up or down points to be able to get that 0 for idle, 50 and 100%, or however you want it, your flying style dictates, to get that throttle response you're looking for. So you can throw that throttle curve right in on your throttle channel on a fixed wing aircraft. Flight conditions, we've talked briefly about flight conditions, but that's kind of a different story altogether. We'll cover those later on. But this is where you can get into your flight conditions, allowing you to have multiple settings tied or attributed to a flight condition. So as we switch into condition 1, 2, 3, and 4, 1 being normal, 2, 3, and 4 may be all different types of mixes, all different types of setups. You can easily access those. If we wanted a 3 position on a fixed wing, switch E as 3 position, normal, condition 1, condition 2, and then I can additionally throw in a condition 3 or whatever, or 4. Or I can be in normal mode and throw in condition 4 on another switch. It takes me to those other sets of settings versus having to assign a custom mix to each one of the different switches and then activating those as you're flying, and it can get a little bit complex. The flight conditions are really handy for that. As we switch on to page 2 for Acro, timer, monitor, and throttle lock. Monitors, throttle lock is kind of handy. If you power up your aircraft and you don't want the engine to, or the motor to, inadvertently spin up. If it's electric motor, you don't want to mess with the throttle. You want your fuel engine sitting there at idle, and no matter what you do here, it has no response. You can throw your throttle lock in, assign it to any one of the 2-position switches or a 3-position switch even, and as long as that's thrown, your throttle's not going to do anything until you activate the throttle again off the switch. Monitor is servo monitor, that actually, or channel monitor, that actually kicks in on all the different models as well. And as you can see, my throttle's at 50%. There we go, 0. Now I take it to 50%, and we see that we do have everything pretty much in, in the center position. It's going to show channel 1 through 7. We don't have anything really assigned on some of those more advanced channels right now. It's all set up by default. As you assign switches to channels, then of course the rest of those will become active, or sliders to channels, they become active. Right now, by default, it shows our 4 channels that are active there, channel 1, 2, 3, and 4. You do have the option of going over and testing that, which we can go neutral. That'll touch this takes everything to neutral and tests our neutral position, so you can monitor where your servo neutral is. You can also go to move, and what that'll do is move channels up and down. It'll simulate that movement. Since this is tied to channel 5 right now, we don't have anything assigned to it. If I move that over to channel 4 even, we would see our servos start to move. So all of our servos are going to move 100% throw as it's set up on the monitor. Again, make sure your prop is disconnected. This is going to move if your model's active, it's going to fire up the motor or make changes to or move all of the channels around, so be careful about it. So we can go ahead and exit out of the monitor, the move monitor, the channel monitor and the move function. Timer, again, timers are timers. We can go through and adjust all of our timers there. Timer 1 and timer 2. We have 2 available. We can assign those to switches. We can choose up or down. We can choose to assign those to the throttle channel. Here's switch A, B, C, D, and E, and F. And we can also put it on the throttle channel. So as we move the throttle channel, it's going to go through and activate it. So as we get maybe past idle, it'll kick our timer on. So we've got a lot of options there. We'll go ahead and take that back down to null. Oh, I chose switch A. Go back here and choose null. There we go. So those are all of our Acro functions. Again, a lot of these are base level stuff we're going to cover a little further on: dual rates, Expos, EPAs, things like that. So let's go ahead and take a look at the next section. So I've set up a test Heli model. I just chose, I think, 90 degrees, single servo swash plate, but we can go through and adjust all of that and get a feel. In fact, what we'll do is, since Test Heli is already created, or I've created one just by default settings, I'll go ahead and jump into the system level menu, both button depresses, and now I can go through model type, model select and model type. And my model type, it's going to bring me back to the initial option I had. This is normally what you have when you create a new model. Type Heli, and then this is where I can choose my swash plate. 90 degree 1 servo, 123 servo, and 143 servo. Of course, for our flybarless setups, typically we're dealing with 90 degree single servo, and everything gets passed through to the flybarless controller. So that's why I set it up that way. If we look at, go out to our standard menu, single or main button to press, we've got our reverse subtrim, dual rates and Expos, EPA, Servo Speed, again, all standard. Now we get into our gyro menus. We can go ahead and activate our gyro. Rate 1, we've got 50% normal. We can set our actual gain here. We can go through and throttle lock or normal on that one. And again, your flight modes you're going to set up to your switch and assign everything pretty much to your normal, your stunt 1, and your stunt 2. Heli setup is kind of a different animal. We're not going to cover that in depth on this particular screen. There's a lot of resources out there. The cool thing about the Flash 7 is it does accommodate all of those setup considerations in terms of menuing, features, and assignability. But you have your gyro menu. You do have your throttle cut, your throttle hold, which again, throttle hold is a big thing in helicopters. You're going to set that to a switch, and with more switch options at the top, usually you pop that over here. I've always set it up where this trainer switch is and used another one, but you're going to want to set a 2-position switch for your throttle hold, and then also your normal stunt 1 and stunt 2. So programmable mixes, we do have 3 of those, custom programmable mixes. Revo mix, which we can go through and activate. And it gives us our rate Expos switches assigned to, and then also you can activate the mix on that as well. We do have second page of our Heli list, and this is our swash to throttle. So we can go through and put our mix in there, swash to throttle. Our throttle curves, which we'd expect on a Heli setup. We have our pitch curve, which we'd accept on our Heli setup as well. There's a standard 5-point pitch curve. And you know, again, that would be set up. Your pitch curve would be based on your throttle position for positive or negative, depending on if you're running in normal mode or stunt 1 or stunt 2. Flight conditions, you can have your idle 1, idle 2, and hold. So those are your normal idle 1 and normal idle 2, and then hold. So you would have your normal set down in a low position on switch E, which is common, and then you would have your idle 1 in the first position, and the second position or center position, idle 2, and the second one up. And you just need to assign those to the switches. So what we do is go through here, say switch null. We're going to go ahead and make that switch E. And you see here the way to set your switches or assign your switches in the Flash 7 is if we have idle 1, we want that in the center position. All we do is go through and we say, let's go ahead and turn that to on. And then we'll back out. And then we'll go to idle 2. Switch is E. Idle 2 is on. Okay. And you see now it reflects it in the menu. Normal, idle 1, idle 2. And then we can set our throttle hold here and choose which switch we want to put that on, which, depending on how you want to do it, you could make that E or D, I suppose. Probably D. That's what I do on this radio setup. So there's our switch D, and it shows the position of it. Throttle hold would be on in the down position, so we'll go ahead and turn that to on. And there we go. So now we've got normal and hold. This is our throttle hold, and then we've got our flight condition normal, idle 1, and idle 2. Of course, that'll override it at any given time with the 2-position switch when you throw throttle hold on, regardless of where your flight condition's at. It'll always override it. So it goes up the list within your flight conditions. Timer is standard. A monitor, we do have a swash ring setting as well, and then of course throttle lock for our Heli setup menu. And now we'll take a look at test glider. We've been and created a model called the test glide. It's going to give us all of our glider menu options. So go into our main menu, and now we've got, again, familiar, reverse subtrim, dual rates, Expos, EPA, servo speed, all common with all types of aircraft. Aileron differential, we can set aileron differential in there as we can with 2 servo or a multi-servo setup, fixed wing or acro. Programmable mixes, we do have our same 3 programmable mixes, custom program mixes. Comes set up with aileron to rudder mix and also elevator camber mix. And then additionally we have our camber mix settings on glider, so we can go through and set our camber exactly as we desire for our model type of setup. Flap conditions, since I set this up as 2 ailerons, 2 flap servos, we do have offset, which we can apply to any of our servo combinations from our flaps to our, if we take a look and activate that, our aileron, elevator, and flap, we can set our offsets. So we'll go ahead and inhibit that again. And now butterfly, so we can set up our butterfly as well, since this is a glider. It allows us to set the speed as well as to when the butterfly kicks in. Your butterfly is kind of your stall braking. You can go through and assign that to your throttle channel as you go down through 50%. You know, assign 50 to 100 of your throttle is actually your throttle curve to give you 100% representation on your powered glider, and then as you go below 50%, maybe that kicks in your butterfly to slow things down. So you can do that. As again, you can make that switch, and so again through switch we have the option of tying that to any number of switches as well as our throttle stick. So we've got our line, a divider point, and then the entire line of the throttle's travel. So we'll go ahead and make that inhibited. Flight conditions are, again, flight conditions up to 3 total. Well, including normal is 1. Your normal flight condition, you have a total 4. Now the cool thing about this is your acro or your glider does come with speed, your thermal, and your launch. So you do have 3 different conditions already set up within the transmitter that accommodate glider configurations. Speed and thermal and launch, you can go through and go into there and choose the switch, and of course the speed at which it arms. So you then can go in and modify each of the settings for those 3 different flight conditions. Timer is the same as the others. Monitor again is our channel monitor, and throttle lock. So we can go through and lock our throttle while we're walking out to the line, which is very common in a lot of our power glider setups, especially those which use 100% for competition. It's full throttle and then cut it off and off you go. So we do have that throttle lock that's available for any type of setup. And that's our glider list, page 1 and page 2. So it gives you a lot of pre-programmed stuff that really accommodates your common glider setups. Let's get into some of our basic programming, reversing and subtrim, for example. Let's see, we're on an Acro model right now. It's going to be the same for all model types. We'll go ahead and just go into our first level menu by holding down the main button. Reverse is the first item. Click into that, and then you've got channel 1 through 7 that you can reverse any of the channels from the screen. We've got aileron here. This is right now going right and left with the stick. Let's say we wanted to reverse that. Normal reverse. And there we go. Happens instantaneous. You can do that to any of them. To change it back, select it, scroll to the left or the right depending on where it's at. Hit the enter button or press down on the main button, and you're back to normal. Now the next thing is subtrim. Next item on the menu, common on all model types. Subtrimming is when you put in a servo and you fire up the servo inside the system or inside the aircraft. First thing I do is make sure that it's going in the right direction, so I set my reversing. Then I look at where its position is, and I line up my servo horn to be as parallel or perpendicular to, I guess the control surface as possible. That way I have equal throw, as equal as I can get off of a rotary servo, but my servo horn is centered. It's usually is slightly offset. Like for example, well, this is an extreme example. We'll go ahead and subtrim this to where it's in line or parallel with the servo body. So that's hooked up to channel 1. We'll go ahead and go into subtrim. Channel 1 is aileron, which we want. We'll highlight that, select it, and then we'll start subtrimming. And you'll notice as I turn the dial, it starts moving. I get it to where it was so far off, it's actually at 100%. So that should be moved to the next spline. You never want to have to trim that far. But there is something kind of interesting that can take place too behind the menu in subtrim, and I'll show you that in a second. So let's go ahead and trim it up. In this case, we'll just go to 100 as far as we can go without moving the spline. Hit enter, and now we've got our servo. All we did was take the center position of the servo and move it. We didn't change the end points at all. We just moved the center point. So now we've subtrimmed. The cool thing about that is, and as we go out to our main screen, say we're in flight and we're banking to the right or banking to the left, and in this case we're banking to the left a little bit, we still have our main trim adjustments. We haven't affected those, so we can still change our trims in flight to get stable flight without running out of trim, and that's why you sub-trim first. Get them as parallel as possible or lined up as well as you can visually. That way you've got plenty of trim in the air. So now you see I can continue to trim it while I'm in the air and I still have plenty of control. Now these trim steps, each of these, a single click moves the servo to a certain point, and it's represented on the main screen. That's our main trimming. What we want to take a look at is something that's kind of cool inside the radio system. If we go into our main or our system menu, we can go through and adjust our trim steps. So right now by default it's 12 steps per trim click. Now this is pulse width modulation, so 12 steps is essentially, I'm not going to say this for sure, but it's about 12 microseconds is what it's stepping it. You can change that significantly. So say trim 1 is our ailerons here, and you notice on each click it doesn't move that far. It's moving very slow. I'll get it centered back out here. There we go. We'll go back in and do our trim step. I can take that and adjust it all the way up to 100 trim steps. And now, well, even more than that, 150, is it? Oh my gosh, it's still going. 200 trim steps. So we've got 200 trim steps. I'll exaggerate it here and show you what that means. So now, when we go out to our main menu, see the amount of movement with each click? You actually max out the allowable trim. And there it is. It's 200 trim steps. So I've essentially got, from center position, I've got 1, 2, 3 trim steps because it's jumping that far for every click. So we'll go ahead and go back into our trim step and adjust that back down to 12. But that's adjustable. So if you find yourself, you know, clicking, click, 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 and it's really just, it's like, wow, it's not really responding, you can double or triple that 12 and find that you're getting a little more movement, significant movement with each trim step, which can come in handy, especially if you're not really comfortable or you got a really adversely behaving model and you're having to hold sticks in strange positions and try to trim on your maiden flight and it's just getting out of control. You may bump that up just slightly to give yourself a little more flexibility with each trim click. So that's our trim step that's below sub trimming, and that also covered the basics of servo reversing. Dual rates and Expos, one of my favorite features of any radio system, and the thing that it takes a radio from being a transmitter from being just a basic 4-channel or basic 6-channel into being a computer radio, something that gives you flexibility and in dynamic conditions you can set up on your airframe. So the most important thing you'll probably find yourself getting into to fine-tune your model is going to be dual rates and Expos. So let's go ahead and use our test acro setup. You're going to go through the first level of menuing for that. And there's dual rates and Expos. Hard not to explain dual rates and Expos if you don't know what they are. Dual rates allow you to assign 2 different rates of throws. So say, for example, normally when you do your aileron off to the right, you get that much travel. When you would, and this is just me mocking it up, when you throw your stick, it would only give you that much travel. And so that's low rates, high rates. Low rates, high rates. So if I'm on high rates, I've got equal deflection. If I throw it on low rates, maybe my total deflection is only that far. But instead of having to control that with a stick, you just throw the rates on. So we're going to go ahead and set that up. The other half's Expos. We'll explain that in a second. So right now we'll use that aileron channel. There's our full deflection on ailerons. We'll go ahead and go down through and say, all right, let's go with dual rates. First thing we need to do is assign it to a switch. I typically put everything on one switch. In a few models I'll want separate control for rudder or separate control for elevator, but typically if I'm just flying something to get a feel for it, I'll throw everything on one switch. So in this case we're going to use our D switch. We'll go ahead and choose switch D, enter that. So now all of a sudden we've got 2 conditions. As soon as we make changes now, it's going to be based on our current switch's position. If you notice, there's a 0 right there, showing it in 0 position, and there's the 1 position. So let's start off with our dual rates. This is our full rate, say full forward. So we'll switch it into mode, or into position 1, and we'll adjust some dual rates down here. So, and this is for our aileron. We're going to go ahead and choose 50% travel, just for visual perspective, or visual purposes. So 50% travel on our up and down deflection. So this represents both up and down, which is left and right. Left and right, up and down, L-U-R-D. So we'll choose 50% either way. So you can set different rates for different directions. So now it's in 50%, and you'll see what I showed before, what I explained before is going to happen based on a switch. So there's our 100%, there's 50%, without me moving the stick. So there's your dual rates, easy to set up. Now the other thing we can do is we can go to our Expos. So we've got our dual rates set up now. We'll go ahead and back out, and we'll go down to Expos. Now exponentials, the simple way to describe it is exponentials, in this case, we're going to put negative exponentials in on a Hitec radio system, and it's also for Futaba. If you're running with Spectrum radio systems, it's positive exponentials to get the same result. A little bit of a different mix-up there. Futaba and Hitec run with a negative number, reduces the sensitivity of the servo at center position, meaning our movement that we experience, we'll go ahead and throw up at high rates to exaggerate that. If I move it, it's pretty linear for the most part. The amount of stick movement is translating to the amount of servo horn movement. If I throw Expos in there, say for example, we want to do that in position 1. Normally what you do is you can have different Expos tied to both conditions, again 1 and 0. We'll just throw it on this main one. So we'll go ahead and dial in some negative Expo. And you see what it does to the curve. Amount of movement is represented by the vertical bar here. Distance of travel of the stick is represented by the horizontal bar. So now when I move my stick left and right, I'm getting less horizontal and vertical and movement on the actual graph itself, and we'll explain that here in a second. So say I throw in, we'll do some pretty extreme stuff here. we'll go minus 75 on both of these, so it really exaggerates it. 675, okay. So now in this rate, in my low rates, I have no exponential sitting there, but in my full rates, I have a negative 75 exponential. And you see there's like pretty much no activity. See how I'm moving my stick, and I'm getting very little movement out of my servo, but as soon as I get to my extents, it makes up for it. It's like right at the end. I'm getting 100% of my full servo throw or travel, but it's doing so in a much less sensitive fashion at the center of the sticks and more activity towards the end. So it took that PWM signal and it kind of stretched it out in the center a little bit and compacted it either side. This is nice because when you're a new pilot, your hands tend to be a little twitchy. You know, you're up there, you're flying, your nerves are cranking, your adrenaline's going. You see all that stick movement? It's translating to very little aileron movement in our example. So I'm sitting there and I'm twitching, and that servo's not going crazy on me. Now, if I take those Expos out, well, even an example, let's see, let's go ahead and dial that back to 100%. You'll see that those twitches translate to control surfaces. So now, when I'm twitching, you see that? All that little movement actually shows up on the servo. So those are your exponentials. Dual rates and exponentials happen on the same page. The thing you're going to mess up on, if you're new to this is your first time setting them up, is you're going to find yourself forgetting which position the switch is in. So you're like, okay, I want 50% travel, but then I want 30% expos, and you'll forget that you actually switched it, and you'll go through and it's like, this doesn't make sense. I'm getting really weird responses. Let's make sure. Typically, or most common, is full forward is full rates. Pull it towards you is half rates. So think, I'm pulling back on my control. I'm pulling back on my responsiveness. I'm going back out, you know, all full forward. So that's your dual rates and expos. And then you just assign them to a switch and you're off and going. Now, what you can do as well, you don't have to have everything assigned to one switch. In this case, we do, just our ailerons, but if I wanted to go through and put my elevator dual rates in there, I'd have the choice of saying, all right, maybe elevator I put on A or something like that. So, you know, maybe I put my rudder dual rates on switch E and I put my elevator dual rates on switch A. You can do that. Choose a control surface you want to affect, go through and immediately choose a switch you want to put it on. So the elevator is going to be on A, switch A, and now immediately you'll see there's position 1 and position 0. When it was on null, it didn't do anything. That state didn't change. Put it on A, and we've got our conditions. Go through and apply all that for your elevator. Likewise, if you want to do your rudder then, go through and put your rudder on switch E. And now suddenly we'll find out we have 3 positions. So we've got position 0, position 1, and position 2. Let's set all your changes. Likewise, you can go through like I did for a lot of my models. I'll take my rudder and say I want to use switch D for that. Okay, and now even though I'm on rudder, it's still going to reflect the changes of switch D. So I kind of group everything together. It's an easy way to start off. You can do it however you'd like. So that is a dual rate and expos. All right, endpoint adjustments, or EPA. That's the next thing we're going to cover. Endpoints, I tell you where they're used most often is when your linkage doesn't allow for the proper travel or too much travel. Either you have too little or too much travel, and it results in either over-deflection of a control surface or servo binding, which is something you want to avoid like the plague. When your servo's binding, you hear that grinding? That's a servo working its tail off to try to center itself back where it needs to be. There are some adjustments at the servo level where you can adjust the deadband and stuff on programmable digital servos, but generally, you know, you want that servo to be fairly quiet. In some models they aren't, some servos they just aren't. They squeak a little bit or grind a little bit. But what you don't want when you throw it in one particular direction is to bind. So we've got it, we've got this at channel 4, which is our rudder. So say when we throw our rudder this way, it gets quiet again. Say it's binding. You hear that constant squealing. And it quiets up when you bring it to the center position and it binds again. You want to adjust that endpoint position, or EPA, endpoint adjustment. We're going to go into our main menu here. We're going to go to EPA. And I'm going to switch this over to, you know what, channel 5 and assign that to a switch and make it a flap servo. That way I've got a switch to work with. It's a little easier than the others. So let's say we'll go into, you'll be able to see how this is done. Push both of these, go into channel. And I'm going to go through and adjust my channel 5 aux to, we're going to make that, instead of aux, we're going to make that flap. There we go. and we're going to assign it to switch B. There we go, and now I've got my flap assigned. So going back into our main menu, we're going to adjust EPA for the flap now. So we're going down here to channel 5, which I just reassigned to flap. And we're going to say at 100%, you know, this thing's, say, flaps all the way up, all the way extended. Maybe in my all the way up position, I'm just getting some binding. I hear that squealing going on. So what I do is I'm going to hold my finger on it to simulate binding. I'm going to go into my flap channel, and I'm going to adjust that, and there it goes. It got quiet. So by just taking that a little bit further than what my finger was at, and there's my 100%, it's binding, back it up just a little bit, and now I got quiet. So what I'm doing is actually adjusting that endpoint. So if I dial it all the way down to like 25, and I go over to the other direction, and I dial that all the way down to 25, what I've done is effectively adjusted the amount of travel that servo's making, and you can see that. It's barely moving now. So if I want more deflection in one way, I can actually see that real time if I switch to that direction. I can go all the way up to 125% travel, and in this case, I'm barely past my center line in the opposite direction, and I'm all the way over there. So this is the end point. It's stretching and compressing that PWM signal to be able to accommodate the stopping point that you want for your servo. So if we look at that on a standard channel with, take that back up to 100, we take a look at that on a standard channel with an actual gimbal assigned to it, say for example on our ailerons. If we go up here to aileron and we say, all right, we're going to go ahead and make aileron travel endpoint 50% and 50%, what you'll notice is it stretches and compresses that PWM signal to be able to accommodate full control or full input travel, but then that only translates to a portion of movement, a small portion of movement. Whereas if you did servo travel limits, which are different than endpoints, not covered in this particular explanation because the Flash 7 doesn't do servo travel adjustments, that at that point would actually, you'd see the stick move and it would lose its effectiveness. The stick would keep moving and the servo wouldn't move any further. That's your servo travel limits. So different application, different use. EPA is by far the most common one because it stretches and compresses that from a perspective, or from a conceptual perspective, it compresses and contracts that PWM signal, giving you that good feel on the stick, but the travel that you're looking for. You can overdrive the servo within allowable limits, 125 in both directions. That's not going to hurt the servo a bit. It's not going to overdrive it. You're just going to lose a little bit of resolution, so it'll be a little more granular. But unless you're a pro pilot or using it on a very small control surface, you're not going to see the difference. So there's 125% travel, and we can take that back down to 100. And that is endpoint adjustments. Very handy, especially in flaps or retract, gear, stuff like that. Little different applications like that. In fact, in some cases, you may have to bounce EPA if you're trying to set up electric retracts and you can't get them to arm. They just won't throw the way you want them to. You may have to bump the trim. The trim doesn't work. You can bump the EPA just slightly to take it a little bit further, and then at that point, you'll notice things will start working properly. Endpoint adjustments. Servo Speed is another feature. Very handy. Within the radio system, you can adjust the travel speed. So say, for example, we've got our flap servo here that we assigned to a switch. We want to adjust the speed of that to be more scale-like, so it very softly extends the flaps, and not just from a scale visual perspective, but also from a handling. If you throw in flaps quickly, that definitely changes the aerodynamics of the airframe very quickly, and can abruptly balloon the aircraft or cause adverse reactions. So servo speed's kind of handy sometimes. We'll go ahead and go through into our first level menu, push and hold down, and we'll go to S Speed. Same on all model types, Servo Speed. We're going to use that flap servo that we set up. We're going to go ahead and increase the delay. So when you dial in a positive number, you're increasing the delay, and you can increase it all the way up to an insane slow speed. It takes a long time to get there. 25. At 25, that servo's actually moving. I'll hold up to the microphone. You see it's just slowly getting there. Well, we don't want that. That's too long. So, you know, pretty good speed that I've worked with before. Move that up in the menu a little bit here so you can see it. There we go. You know, it's 2, 3 delay. A setting of 2 or 3 is pretty good for a lot of applications. You may want to go a little bit higher if you've got a real scale application, but you know, say 2.5. There we go. And that's a nice slow speed then for our movement. You wouldn't want that on ailerons or anything like that. You'd want that on, you know, mechanical gear, or you'd want that on flaps, other control surfaces. You know, if you have some things that can deploy slowly and are more flight condition type control surfaces versus active control surfaces. But that's servo speed, and you can assign that to any of the 7 channels on the Flash 7. As you can see on the list, it starts at 1 and goes all the way down through to channel 7. So now we're going to go ahead and move into our system level menuing to give you some of those more advanced features and setups and capabilities of Flash 7. Hit both buttons at the same time. A lot of these are going to be similar between the different model types. Model select and model type we've accessed from the main screen. If you recall, I can go down through here and choose my model and get into that level. So it kind of lets you peek into some of those advanced menus from the main screen. Same thing with the Spectra module, which is the actual 2.4 gig module built into the radio. We can go through and bind and range check and all that good stuff. We'll go ahead and hold down both buttons here, and that's going to bring up the full menu for the system level, second level menu. Model select, model type, already covered those. Channel. The cool thing about the Flash 7, it's a lot like the Aurora 9, it's a lot like the other more advanced high-tech radio systems, is you can go through and assign any channel to any function and then any switch or gimbal. So say for example, you know, rudder, we got a second elevator, or we got a second aileron. In this case, we've only got 1 aileron set up for this aircraft. Well, after the fact, you can go in and say, all right, well, I want channel 5. And people ask, well, why don't they put elevator, aileron, throttle? That's easy and simple for newcomers, and definitely more easy than a numbering system, but it doesn't accurately reflect what all the high-tech receivers can do, and that is you can reassign any channel to any function. So channel 1, 2, 3, 4, 5 is much more accurate. You learn very quickly. Channel 1 is aileron, channel 2 in mode 2. Channel 1 is aileron, channel 2 is elevator, channel 3 is throttle, channel 4 is rudder, and then they kind of go on from there. Channel 5, typically if you got 2 ailerons, is your second aileron. Channel 6 would be your second, your flap, or 5 would be your flap, 6 would be your second aileron. It really depends on how it sets up on the radio system, but it kind of changes from there forward. Cool thing is, through channel view, I can see exactly what's assigned to what. Channel 1 is aileron, channel 2 is elevator, and down through the list. If I want to reassign, it's as simple as saying, all right, in this particular configuration, I want my aileron 2 to be on channel 5, and I want that to be controlled by, I can assign which stick, you know, channel 1, channel 2. Well, I want it to be on J1, which is fine. So we'll leave it on J1. So now all of a sudden, that went from being an elevator to both of these are now channel 1 and channel 5 are my aileron servos, and I just assigned both of those. You'll notice I'm moving at different speeds because this is a much faster servo than this one. So, but it's really easy to go through your channel list. Very handy thing. I use it all the time when I'm setting up models. I don't really concern myself too much about model wing type, other than, do I want, you know, elevons? Do I want, you know, particular unique wing style? I don't worry about the second aileron servo or the second flap. If it's conventional, I just choose the basics and then go through after my setup and assign my channels. You can do it however you'd like, but you can always get in there after the fact and make changes. Trim step we already covered in sub-trimming. Trainer is simple. You go through and can either choose all, which gives all function and controls that do map or can map to the trainer radio, to the master, or you can choose just the gimbals. You can go through and say, I just want the sticks to pass through. So all you've got then is J1 through 4. That gives you a switch, which you'd assign to, you know, in this case, usually F is the best one because it's a momentary. And we say, all right, we're going to make, when I pull that, that's trainer function on, so I'm going to make that on. So now they only has trainer. The trainer only takes over. The student radio only takes over when I have that pulled. If I need to take control back over, I release it and I'm the master again. So, and of course mix, you can actually activate or inhibit a mix itself. The mode, let's see here, if we take it back from stick to all, that's going to give us all of the functions, all the way through channel 7. So if we have conditions and all the stuff set up, we can use those with the trainer. Sensor, neat little thing too. The sensor is when we get into all of the telemetry sensing. We did a separate clinic on telemetry sensing. It'll take you in detail. Essentially, the Flash 7 is compatible with all of the sensor stations. There's multiple ones available. This is the advanced, or no, this is the for electrics. So it's going to be lacking the variometer and some other sensor capabilities. This is for electrics. This is for nitro. What won't function on the Flash 7 is actually the fuel sensor. They didn't carry that over on the 7, but all of the other sensors should work just fine, or will work just fine. And then it's fully compatible with the advanced sensor station, which has the variometer, the airspeed indicator, the servo manager, and I think I'm forgetting one. But it has some more advanced sensors on there. So we've got this electric here. Let's go ahead and try to connect it and see what happens. Let's go into sensor. And then we've got our GPS, RPM, temp, battery, servo, and advanced. Of course, underneath battery is going to be our voltage, current, and wattage, which has inductive, current reading, inductive rings. You have voltage, which just ties directly into up to, an extremely high voltage. It'll do a 6S battery pack, no problem. And then you have your wattage, which of course calculates your current and your voltage and gives you your wattage consumption and all that good stuff. And then what you can do is go back out here to servo. There's your servo monitor, up to 4 servo monitors. RPM, you've got RPM 1 and 2, which can be either magnetic or optical RPM sensing. GPS is their GPS sensor. It'll tell you here the lat, lon, altitude, airspeed. And then you can choose again there your metric or your imperial unit of measurement. And then altitude absolute or relative to where you took off, so 1 foot off the ground wherever you're standing is 1 foot, or relative or absolute, which goes off of sea level. So it's going to already calculate in where you're starting off at from above sea level. So when we go to advanced, we've got now our airspeed indicator, our variometer, and then tied to our variometer, we can put a climb sound. So you'll get a beep, 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 a climbing up beep when you're in a thermal and you're getting lift. And when you're sinking or you're out of lift, you'll get the sink sound as well. So you can turn those alerts off and on there. So let's go ahead and take a look at, I've got a couple temp sensors hooked up to this one. We need to plug this into the data port on our Optimus 7. Like I said, I don't want to get into this at length. It's just a quick little way to show you what it displays. We do a full in-depth configuration and stuff on the telemetry sensors in another clinic. So let's take a look at the data. The data channel needs to be tied in, or the data connection. And then the sensor stations need both power and the data connection. So this goes into the data port on our Optimus 7. That's the right polarity. There's our data port. And then this plugs into, you can be wide off the internal part of the power supply, wide off of, and it just needs to pick up bus power to power the unit. So we'll just grab a channel 3 here because it's open. And that will, right there, and immediately we see, as soon as it gets power and the data channel is connected to our sensor station, we get temperature 1 and 2, and you can see that change as I hold one of the probes. There, I've got temperature 1. It starts going up immediately. Now this is in Fahrenheit. You can adjust this to be in Celsius as well. So depending on your locale. And there we go. So that's the sensor stations. Let's go ahead and back out here. Out of sensor, we have Spectra. This is our module, our 2.4 gig module in the back, or built into the radio system that allows us to bind to or ID link to our receiver. Range check, binding, scanning. We've already covered that. Mode, this is where we can choose our mode depending on our nationale. Mode 2, Mode 3, Mode 4. It supports all modes 1 through 4. North America, typically your mode is 2. That's the most common one we use. Management gets into the layer, the back end. So for this video, I kept the backlight off because it was so bright it was just messing with the gain, and trying to get the two to balance out was difficult. But you can choose that to be on 5 seconds, which here goes, you're not going to be able to see it anymore. 5 seconds, 10 seconds, 20 seconds, 1 minute, 10 minute, 30 minute on, 1 hour on, or always on. So you have several options on your backlight timer. Contrast, it's adjustable up to 10 from 0 to 10. And you can see that contrast getting pretty strong there. I think default's 5. Battery type, this is where we get into our cool different battery types. We've got alkaline, we've got life. Now you'll notice it's going to be alerting me because of my battery voltages are below life. So this status indicators are one of the last things we're going to talk about. It can really give you a lot of good feedback. There's a lithium iron phosphate or LiFe batteries, nickel cadmium or nickel metal hydride, similar cell voltages, LiPo, lithium ion polymer, or LiPo batteries. So depending on the type of battery you want to run inside the radio system, you can switch it and it'll auto cut off at the appropriate voltage to keep from over discharging a LiPo or causing problems. So we'll go ahead and go back to alkaline. You see it's happy now because it knows it's on a lower voltage cell. UI feedback is the beep, off, on. There it goes. We'll turn that, we'll leave it on for right now because I want to show you a couple things. For one, when I go up to battery type, normally our visual alerts are backed up with an audible alert as well. And you see that. I'm on the wrong battery type for the type of voltage I'm supplying to it, so I get an audible and visual feedback. And then we've got UI feedback on, and then warning setup. So you've got warning setups. RF check is on. That's the first screen we see when it says, do you want to transmit, yes or no? The second thing is high throttle. So if we turn our radio system on, we've got flight condition and high throttle. So we need to have a flight condition set up in high throttle. I'll show you that. I don't think we have. I think my no name has a, select that, switch to that model. There we go, we got a flight condition. So two different ways this model is going to gripe at me, or this transmitter is going to gripe at me now. If I turn it off and I pull my throttle up, it's going to get mad because my throttle's not in a zero position. It can create a dangerous situation. So turn it on. Do I want to transmit? Only when I'm going to transmit does it detect our situation. So if I said no, it could care less. I'm going to say go ahead and transmit. And now I'm getting my visual cue and warning throttle high. I have to zero my throttle out. And then the actual radio starts transmitting at that point. Likewise, if I had my flight condition enabled, because that could cause a hazardous situation. It could be a landing flight condition or a climb out or who knows what. It could have things set up in ways that aren't desirable by normal operation, and it may take you a second to realize, oh my gosh, it's doing weird things because I've got it in flight condition 1 or 2 or 3. So if I kick my flight condition on now, turn on my radio, I tell it to transmit, I very quickly got a warning flight condition, and since flight condition isn't tied to a throttle channel or anything else critical, all it gave me was a quick little flash of warning. As you continue to increase your assignments within your flight condition and affect different primary channels, especially the throttle channel, it will tell you something's going on here. This is not a good situation. Likewise, on a helicopter setup or heli setup, if you've got your flight condition out of normal for stunt 1 or stunt 2, if you actually enabled the radio system, that would immediately plow power to the main drive motor, and you could cause massive bodily harm. So when flight conditions are set up in heli mode, you'll get a dead stop on the radio telling you need to move back into normal mode before you actually all start transmitting and talking to that aircraft. So those are your initial setup warnings. So we'll go back into that menu, hold both of them down, we'll go back into management and warning setup. And we've checked RF check on. You can turn that off. If you don't want it to ask you, it'll just automatically transmit every time. High throttle on and flight condition on. So that concludes pretty much everything that we can talk about on the Flash 7. There are a couple things. We covered flight conditions off and on throughout. Virtual channels is something that's kind of interesting that is in the Flash 7. If we go into the channel menu, you're going to notice additional channels, VC1 and VC2. There's 2 virtual channels. So when we get into programmable mixes, say we go out here to our main menu and we go into our first layer, settings menu, we can go into our programmable mixes, which are on the second page in Acro. Oh, no, they're on the purse. Here we go. Now I can choose from one of my 3 programmable mixes, and I can go through and make that active, say program mix 1, and I can choose what I mix to where. So what it allows me to do is actually create another mix, another virtual channel mix, assign that channel to an actual function inside the channel page within the settings menu. It gives me 1 more channel, 2 more channels actually with VC1 and VC2 to be able to create new combinations of mixes or new combinations of functions within the radio system. So it's a pretty cool feature. Having and you just choose those. They show up like a standard channel. So say for example I'm here and I want to choose what the source is. Well, rather, yeah, say the source, and source is virtual channel 1. There we go, virtual channel 1. I can mix that then into any of the other channels and create another condition for my flying or for my operation of the aircraft. So the programmable mix, the virtual channels 1 and 2 are a pretty cool feature. The Aurora 9X has some virtual channels on it more than the Flash 7, but they went ahead and pulled it into the Flash 7, which is another unique feature. Whether you use them or not, it gives you that additional flexibility for programming layer. Hopefully you're set up to operate at least the basics and some of the advanced functions of the Flash 7 radio system. Very powerful, very capable radio. Again, 4096 resolution, 7 millisecond frame rate. Very fast, very responsive, and very precise. If you'd like more information, you go to the Hitec website at hitecrcd.com. If you need some general clinics on different radio functions and the basics of how they operate, you can always go to our website at tobefly.com. Go to the knowledge base and check out radio systems. I'm Kurt with Two Brothers Hobby. Good luck with your Flash 7, and thanks for watching.